tell you the plan for the day. We are going to start with that dating popcorn dating, whatever it was called. I can't remember. Dating popcorn is what it says up there. Activity. You remember on Friday, perhaps, that I gave you those bags of popcorn that were popped for different amounts of time? Is that sounding familiar? They were kind of nasty, and I only gave you like 4 minutes to count 300 and some odd kernels. So here's the plan. I did not pop more popcorn for you because I feel like even if you didn't get all of it popped, you get the idea. And I planned ahead enough so that in my other class, they did get a good count. So we're just going to use their data today. So we're going to use their data, and I will tell you that the thing that really matters to me less than counting popcorn is graphing popcorn. And so we're going to do that today. Okay, so that's our plan. After that, you've got a reading from your textbook that's on Canvas. Some of you may have started that already. I'm not sure, but if you haven't, we will work on that today. And then, could you please stop the chitter chatter? I really appreciate it. Thank you. And then we're going to work on the study guide. You got that study guide on Friday as well. The reason for all of this is that tomorrow we're having our Unit 3 test. Okay? Tomorrow is the science finals day, and so that's when we're going to do our test. That's Tuesday. Then we've got Wednesday and Thursday are the last 2 days of this trimester. We've got one more little project that we're going to work on just to kind of wrap up all of that stuff before you've got a nice long 3-day weekend, and we start fresh next Monday. So we've got a 4-day week this week. We're going to finish some stuff up, test on Tuesday, Wednesday, Thursday project, and then 3-day weekend upcoming. Okay? Questions about logistics before we get started? All right. Would you please pull out the dating popcorn sheet that you have? It was kind of vanilla or off-white or whatever you want to color this. Yes.
It's like almost.
All right. Pull it out, please. Sydney, do you have a pass, sweetheart, or are you just running late? Okay, that's okay. Okay. Really not needed, right? Yeah. All right. So I just want to remind you, because it's been a few days, to remind you what we were doing in this lab so that your head can kind of get wrapped around what's going on, okay? Friendly reminder that a lot of large elements, I showed you the picture of the periodic table, that a lot of large elements do not stay as those large elements forever. They are unstable, and so they break down. They break down through what we call radioactive decay, okay? And that's what we're talking about. A couple of things that you may not have underlined or paid attention to. Your attention up here. I would really appreciate it. And I'm telling you guys, the reason that I want to go through this is that there are at least 3 or 4 questions on the test tomorrow about this material. And I don't want you to miss those 3 or 4 questions on the test tomorrow because you weren't paying attention today. Okay. A lot of the questions that are on the test are over things we've done. We go over 3 or 4 or 5 times, right? You notice that like my capture questions go over the same stuff. This one, we don't have that opportunity. So that means I need your focus. I need your attention. I need your willingness to work with me right now so that you know this stuff so that you're ready to go tomorrow. So we said that there are radioactive elements, things that break down. They break down at kind of at a known rate. And the known rate is related to their half-life. Okay? The half-life is the time that it takes for half of a sample to decay. All right. The reason we care about this, the reason we're spending time with this is because this is how we can date how old the Earth is. The Earth, we know, based on this kind of analysis, is 4.5 billion years old. That's pretty old. That's much older than humans in terms of how long we've been on the Earth. And we'll talk about that later this week. Okay, but that's one thing that you'll definitely want to know. So if you haven't underlined that or put that in your memory bank, that would be a good thing. 4.5 billion years old is how old the Earth is. And again, we know this from half-life. And on Friday, we started doing the analysis to simulate the dating process. Remember, we had the kernels of popcorn, okay? The kernels of popcorn that were embedded in that nasty goo, right? Ugh. Yeah, that was kernel light. It is an unstable element, in big air quotes, okay? An unstable element that decays into popcornium, okay, which is a different element. So we've got one thing that's turning fundamentally into something else. All right. Your groups were assigned different numbers of bags, and then you counted whatever numbers you have here, you're not going to worry about. That does not matter. What I want you to do right now is to take a look at this data here. Okay, it's a little bit hard to read, so if there's anything that you can't read, let me know. This was from your colleagues and classmates from my second period class. Okay, they each put up their own data. So you want to go ahead and write this down now. So your pencils are moving right now. You're copying down this data. Yeah. Pencil. Where's the pen? Yeah.
Oh, pencil. Oh my gosh.
Been through a third of the year and we're not coming to class prepared. Is that what's going on?
I changed my
I
bag for
changed my
basketball,
bag
so, and I
too.
forgot to put my pencils.
Life is hard. You have to sharpen those because they're not sharpened.
Thank you very much.
You're welcome. The sharpener's right over there.
Yes.
Yeah.
Thank you for the guidance.
So the one in the top row for 50 seconds, 19 or 20?
I think that's a 19. Just because I have to add up to 100. So that seems to make sense. So you should be copying down those numbers. These are the percentages of kernelite and popcornium at 10 seconds, 20 seconds, 30 seconds, etc. Okay. So again, this is very similar to the data that you guys would have found had we had enough time on Friday to do all of our counting, but that's okay. The primary goal here is to do some graphing, okay? So if you look just below that data table, it says, using the class data, plot it on the graph below. Let the x-axis represent time in seconds, and the y-axis will represent the percentage of material in each bag. So your graph is going to have two lines, okay? So you're going to do kernelite over time, and you're going to do popcornium over time, okay? What's going to happen to the kernelite line? Is it going to get higher or lower? It's going to get lower, right? And the popcornium, what about that one? It's going to go up, 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 okay? So what I need for you to do right now is to start that graphing process. You are welcome to use a key of using a straight line and a dashed line. If you're somebody that works well with colors and you would like to do that, I've got colored pencils over on the table over here. You can come do two different colors for the kernelite and the popcornium, or excuse me, yeah, the unpopped and popped, so kernelite and popcornium. You need to make sure that you have well-labeled axes, okay? And if you need help, I'm super happy to help you. I'm going to give you some time to work on this. And once you've done this, you can work on the analysis questions. There are two of them right below. On the back are the questions that you need to answer based on the reading that you're going to do. That's on Canvas, so you can just move right on to that when you're ready. And after that, you can move right on to working on your study guide, okay? So today's going to be a pretty self-paced day. I'll probably pause you a couple of times to help you out, but I'm going to let you get started, okay?